Hello and good morning, good afternoon, good evening to everyone. Welcome to today's live stream. My name is Angelo, and today we're going to be talking about how would you make that? On the keyboard, I have my good buddy and colleague, Mr. Brad Tallis. Brad, as usual, will be answering the questions in the chat. So feel free to put any questions you might have in there. And Brad will get those over to me. We use a shared Google Doc, and he drops questions in there, and I look occasionally from time to time. And I'm going to take a moment to make sure that everything looks good. I'm looking over at the chat. Looks good. Looking at the Google Doc. Looks good. Everybody could hear me, I hope. And I got this sun coming right in this window. So let me try to shift out the way. Is this good? Yeah, I'd say that's pretty good. All right. Okay, so let me share my screen. All right. So if you guys remember, a couple weeks ago, Brad made this part. A customer had sent it to him, and Brad did a how would you design this? And I took it, and then I machined it. So let's come over to manufacture. And if we remember, we created this part right here. I could just run through it really quick. Let me just run it. If you guys remember this, actually I should probably just zip right through that. So that was the first operation. And then we flipped it over. That was operation 1. And then operation 2. Let me come here. Let me hide. Whoops. So then operation 2. Let's see. Why is... we got this guy here. Okay. So operation 2, we flipped it over. And let me simulate this guy. Something's wrong with my visibility of things, but then we machined it here. Let me take a look at the chat. All right. While that's running, looks like we got Long Beach, LA, Hungary, UK. Hey y'all, Maria, buenos tardes. We have got Cornwall. Awesome, everybody. Okay, so then we machined this, and then we came to the side, and we put those holes in with a couple of bores. And so that's where we ended up. And so that was 3 operations. And now, let me turn this guy on here. Let me hide that. So we had talked to, there were some people, we got Germany, Serbia, Italy, Bojan. Dobro večer, Bojan. Okay. So when we were making this in the 3 operations, some people in the chat were asking about doing it on a 5-axis machine. Now this part here isn't necessarily a 5-axis part, but what we do from time to time is if you have a part that you need to access maybe different sides, instead of taking that part and flipping it over, actually I got a part here that I've been showing you guys. This part here. I got this guy, and then the first operation. So again, this part here is not a 5-axis part. You guys remember this? I've showed it a couple of times. And actually what I'm going to do one day is show you guys how I machine this one. So this is not a 5-axis part. You don't need a 5-axis machine to make this. But with the 5-axis machine, you could set your Z normal, machine, and then tilt the part, or like if you're doing, say, this side, you can do these features, and you can tilt it, do here, and you can tilt it up and then enter, say, these features here. And those holes are also at an angle. So if you have a 5-axis machine, you can minimize the multiple setups, because if you have a standard 3-axis machine where you're doing it this way and then you flip it, that would be 2 ops, and then you have to set it up this way to do a 3rd op for these holes, and then set it up to do these holes. That'd be 4 operations. They're depending on your creativity and your the application, and is it a prototype one-off part, or are you making hundreds of these? You would approach it slightly different. But I'm just going to be talking about prototyping environment where you just have to make one part, and you need to just get a part on the machine and off the machine as quickly as possible. It's very time consuming for you to build fixturing, make special jigs, things of that nature. Soft jaws on a vise, I've talked about it many times in live streams. That's pretty quick, but then again, still it takes time. You could spend anywhere from 20 minutes to a couple of hours by the time you build all your different jaws for flipping it over. And then also you need to take into account the design side and programming time, the CAD and modeling side, in addition to the CAM side, in addition to the time you spend at the machine. So what's common is you'll start out, sometimes it's called framing, picture framing, or tabs. And I'm going to show you my thought process on this one particular part, and we'll go through that. And again, feel free to drop any comments, and Brad will get those over to me, or questions. All right. So, Marco says, how did I know Serbian? Yeah, Rakia. My family's from Croatia. So if you guys know me from Instagram, my Instagram handle is The True Croatian Sensation, and with an underscore in between. You could also find me via Angelo Juris, and I do post my work that I do here at Autodesk on my Instagram. So, all right. Looking at this part. So as I'm looking at this part, I'm taking into consideration what's the material, what quantity do I need to make, what types of tolerances, and the overall size of the part. And so one thing I typically do to just get a quick gauge of the size of the part, you could do a quick setup. And if you look at the body, you could do a setup with a relative size, and then here you can say no additional stock. And what that will quickly do is give you a box size 7.6 by 5.9 by 3.8. You could also add stock to sides, and you can round up to the nearest, say, 1/4 inch. So your stock here are round numbers. If we were doing this in metric, I would come here for the international audience, and I can now look at my setup. And here, if I look at my stock, and I can round up to the nearest 10. So this size stock is 200 inches by 160 by 100 millimeters. So that gives me an idea of the size of the part. And then right away, as a machinist, I'm thinking, what do I have on the shelf? Do I need to order material? Can I just go out on the shop and grab some material that's laying around? I've worked at places in the past where we had a lot of stock in various sizes. Sometimes the material size was bigger and we'd have to just chop it up on the saw, but we were able to start machining within 30 minutes or so from the time we get the model. I was in an R&D environment prototyping, and an engineer would give us a model and we'd have to start cutting it right away because the part was due the same day or same afternoon, or they needed it yesterday. I'm sure a lot of you machinists can relate that everything needs to be done yesterday. Every part's a crisis. So Just again, talking through how a machinist thinks. So I've got this part. And so Jan wants to know measurements used in Croatia. In Europe, even in the U.S., U.S. is imperial or inch. I kind of prefer metric. And everybody I know in Europe is using a metric. There are some folks that lean towards imperial. I've worked at a place here in the U.S. It's a U.S. company, but we did everything in metric. It was just a company standard. Also depends on the industry as well. So I'm a fan of metric. It just makes so much sense. All right, so again, getting back to this part. I'm looking at this part, and I've got an idea of the size of the stock. But let me just pop back over to the design side. And on the design side, I already started building some things here, how I wanted to hold it. And so if I come into here, I've got this, I created what I call the support structure. And if I turn that guy on, you guys are going to look at that and wonder why I built it that way. So I've got my Haas 5-inch vise with the riser that's going to go on a 5-axis machine. And I'm holding on just here at the bottom, generally about 3 millimeters or 100,000ths of an inch. And I start with my stock. So I have a parametric vise set up here, and I have the stock in there. So if I hide the support structure, you can see the stock that I'm intending to use for this part. So if I started to machine this part, this shape, I would have to be mindful of how I'm going to hold this part. And this is merely a suggestion. This is not the only way to do it. Some of you looking at it are thinking, oh, I would have flipped it 90 degrees, so perhaps the part is sticking up this way. But me, out of experience, I just like to do things like this. It's being supported in 3 points. Let me hide that stock. And because it's being supported in 3 areas, and it's kind of offset, this support here, it's a little bit offset, so the part will just have a lot of rigidity. And then what I would do, I would just start machining this guy. But like I said, I just want to talk about some of the things that a machinist would need to do. So as I create this, and as I'm looking at machining this part, I'm also thinking, where's my toolpath going to go? What boundaries, if any, do I need to create? Like sketches. So if I look at it from the top view and I rotate it like this, and if it's sitting in my machine like this, and I'm looking top down, I'm going to want to machine all of this area. I don't want to violate the support structure, which is this guy here. I don't want to violate that, and obviously I don't want to violate the model. So I will definitely set those up in my setup. But even before I get to that, I need to do a couple of things. And I have a bucket. I call these buckets, where I have some things from my toolpath. I create some sketches. I have this large boundary I created. And this large boundary I created so that when I do my roughing, whether it's adaptive or pocket clearing or something like that, I tell the tool to stay inside that large boundary, inside that blue area here. So it will machine everything within the boundary, but will not violate any of the model. And then the other thing that I do is in that same component, I created this plane. And the reason why I created this plane is it's right on the center of rotation. So when I select my heights for my cutting depth, I will select that plane, and I'll tell it to go below that by about 1 millimeter in metric. maybe about 50,000, sometimes even 100,000 to 3 millimeters below that. So when I'm machining in this orientation and the tool is coming from top down, if the tool is in line with this axis, right, the tool will go below that. I could even select it as a Z depth to go down to this face. So again, I'm just kind of talking through things as a machinist. When I'm doing a project like this, how am I going to hold it? What machine am I going to do it on? What material I have on the shelf? What is the material of the part? What's the quantity? What's the tolerances? And when is the part needed? If it's one part and they need it yesterday, I'll grab whatever size material, throw it on the machine like I showed in that example, and start just roughing and machining it. If I'm making 100 of these parts, and obviously it'd be impossible to make it same day or next day, depending on the cycle time, of course, then I would probably put some invest some time into building some fixturing, so I don't have to start with such a large piece of material. Because when you start with such a large piece of material, you have to machine all of that material away. That's cycle time, and it also costs money for that large piece of material that might be twice as big as necessary. And again, if you're making one part and you're wasting $20 or $50, and it's a $500 part, who really cares? But if you're making 100 parts or 500 parts or 1,000 parts, and it's $20 more per part, you can see quickly the math dictates the direction you want to go. So again, those are the things that I focus on as a machinist where I'm doing a part like this. But again, like I said, I'm thinking this part's needed immediately and it's only one part. So I don't want to build any fixturing. So I take a block of material. It's a little bit larger. And let's turn that stock back on. And I had that stock as part of my parametric setup. That's why it's in this work holding bucket. Otherwise, I would have it up into here. But yeah, so those are just some of the things that I talk about. Looking at the Google Doc, Morgan Olif likes my painting. So yeah, these are both mine. That's an abstract, and that's that's also an abstract. I did that with acrylics. For those of you, some don't know, I used to be a graffiti artist when I was younger, and now I still paint, but now on canvas, and I donate my art to charities. So thanks, Morgan, for that. I know Rob Lockwood commented on that one a while back. Rob's a good dude. All right, so okay, one quick. So I see Marco says, so my father is from Šibenik, Dalmatia, and my mom is from Đakovo, Slavonia. So, all right, and where are you from, Marco? All right, so getting back to this part, I got sidetracked a little bit. I like to talk, if you can't tell. And also, I did want to say, it is a privilege that you guys join these live streams for Brad and I. We do appreciate you guys spending time. I know you're all busy. We appreciate the community here, and we love interacting with you guys. So if there's ever anything you guys need, you can always email me or Brad. My email is angelo.juris@autodesk.com, and we'll be sure to help you out. We are here for you guys. Okay, getting back to this part. So now that I talk through this and I have my stock, I'm just going to hide the toolpath bucket. I don't need that visibility on. And there's my solid model of the stock. And then again, that support structure. When I machine this guy and I remove all the material, I will have the support structure as part of my model that I'm machining and also the part. So I don't want to violate the part or the support structure. And then for the very final operation, what I will do is use a 2D contour. I'm stepping ahead, but I would machine everything, and I would use this edge here and just do a 2D contour along that edge there and step down very small. Depending on the structure or the size of the part, I'll step down 20 thousandths, maybe 10 thousandths, sometimes 50 thousandths, sometimes even 100 thousandths, 0.1, which is about, let's see, so 3 millimeters or so. 100 thou is about 3 millimeters. A little bit, it's pretty close to that. And then I would leave a little web of about 10 thousandths of an inch, 0.01 inches, and then break it off. And then I would have a really thin tab here, a really thin tab there. And then the same thing, I'd be able to rotate it this way and drive my tool on this edge here and come down just shy of this face. And again, leave that maybe about 10 thousandths of material. So when it's done, if I have 10 thousandths of support here and here and here, you will be surprised at how strong and rigid that is. But I would definitely machine everything first with these tabs intact. And also, another thing I'm just thinking about as I'm talking about this part, if this part was taller and let's say it came out further this way, I would leave all of this area solid. Like let's say where this stock is, I would leave all of this area solid if it was sticking out this way and do as much machining on the end and do the finishing of that part as well. No different. Let me grab a pen. No different than if I was doing a lathe part and I'm supporting that part in a chuck. And I've got that part sticking out. Actually, do I have any finished parts? Here's a part I did. And then you're holding that in a chuck, and the part is sticking out. And depending on how far it's sticking out, you want to finish on the end of the part with as much material in this area solid so that it's rigid when you're machining this. And then you work your way back. And I remember on that spark plug bottle opener that I did a while back with Brad. Brad did a live stream on the design of it, and then we I programmed it, then we machined it at Pier 9 in San Francisco. So same process. So sometimes people look at a part like what I have on the screen and say, oh, that part's sticking way out, it's going to chatter. You'll be surprised how strong and rigid that is. So let's switch my screen. So again, those are the things that I think of as a machinist when I'm machining a part like this. So what I would do is I would create my setup, and let's dive into that. Let's go to manufacture. All right. So this setup 5 is what I just created quickly when I wanted to see the stock size. But what I can do, I can just continue on that. Let me change the name to LiveStream, and I will just talk through some things that I need to set up properly to get this type of operation to work. Obviously, I need my model. I can select my model here, so if I deselect this, I could select the model right there. If I cancel that out, I could also just grab the part here. So I can navigate into here. I could grab that body. I could deselect it. If I grab this, that will also work depending on what's under this. So be mindful of that. You can also create components. So let's check. Let's say, what if I grab this whole component? So it will grab everything that's under this component, which is the part that Brad created. It was part 214, and it's that body. It's kind of hard to tell, but it's that. And then also the support structure. So be mindful of when you're creating your components and bringing things in, how you set it up. It can make your life a whole lot easier. So again, if I deselect it, I can just come right here, and that's the part that I'm machining. The other thing you could do is, if you have these separated, if you're doing let's collapse that so it's not as busy. If you're doing some 3D strategies, and let's say I wanted to cut those tabs, and if I had this part structure, support structure as part of the setup, and I was doing a 3D strategy, it would think that the tool is violating that model. So just be mindful of that when you're creating your setup. So I can call it, I can leave it like this here for now. I could also assign the fixture that I'm going to do. And I remember that's going to be here. And I should probably do a little more homework, maybe combine all of these. But I've got a riser, the Haas riser for that 5-inch vise. And then these are all the parts that make up that. The reason why I'm not selecting the whole component is because I have that parametric stock in there. And if it picks that stock, it won't machine it because it's going to think that that stock is part of the model that I'm machining. And we don't want to violate that. Or it would think, did I say that right? Anyway, you guys know what I mean. All right, so coming back. On my fixture, I'm going to grab these guys here. I'm not going to worry about fixture attachment because that's already selected. Now, under stock, instead of relative size box, I can grab the stock from a solid, and I know that I created that stock already here. So now, the stock that I'm machining is coming from that solid. And that solid came from here. I suppose I could show you what I did there. Let me bounce over to that really quick. Come to LiveStream 13. What I did is I created this. Let me open it. Give that a second to open up. And in this, here's all the parts that make this guy up. That's straight from the Haas website. I downloaded their model, and I just made this assembly. And I also created the stock. And that's just a body. I used a primitive box. And what I also did is I'm a machinist. I like to be a nerd. And maybe I'll share this with you guys in the comments when the live stream is done. I created some user parameters to change the dimensions in X, Y, and Z of this stock. So pay attention to the size of this stock. So currently that stock X is 10.5 inches. What if I make that 15 inches and I hit tab? It changes the size of that. Let me move this out of the way a little bit here. Can I make this window smaller? Let's do that. And now my Y dimension, that's this guy, 4 inches. What if that's 2 inches? And I hit tab. It updates and the jaws are moving. And then the stock Z, that's going to be the height in Z. What if this is 2 inches? Now we've got my stock there. Again, I can just come back here and let's make that 5 inches. And you can see how valuable and how powerful this is once you do this upfront work and create these joints and motion links and things like that. I'll go ahead and I'll share this with you guys. All right, Monda, fellow nerd here. Marko wants me to start doing live streams in Croatian. Awesome. Hey, that's a good idea. Maybe Marko can join me. That'd be cool. Okay, so let me do this. I'll do this. Let me save this. And I'm going to drop it into the chat right now. I don't know if it will work with the public link. Brad, you may need to, Brad, you might confirm this or share it. So I'll put it in the Google Doc so you could share it with folks. And I'll also drop it into the chat really quick. So what I'll do is if you have something in Fusion, you could right mouse click and say share public link. I'm not a fan of that word because if you're working on a private design, you don't want that to go out to everybody. I would just prefer that says share document or something like that. But so what you do, you click on this. Did I not click it? Share public link. There it is. This dialog box pops up. And then what you do, you come here to say share the latest version with anyone using. And it creates this URL here. Also be mindful of this. Allow item to be downloaded. Turn that on. And you could also put in a password here. I don't care about this being password protected. So I'm just going to copy this guy. And I'm going to drop it into the chat. Let's see. Does that work? It looks like it did work. All right, and I'll put in the Google Doc, Brad, in case something happens and it disappears. So now you guys can access this file here. And when the other one is done, I'll do the same. I'll share it with you guys. So then you guys can have this. And again, to get to those user parameters where you change the size, you simply make sure you're in design, in the design workspace, come to modify. And go to change parameters. And then this box pops up. And you can create your own user parameters. So this, sometimes collapsed like that, right? So you go to user parameters, you can create a new one. And you can say, let's say I want to put a chamfer or some whole feature in there. I can say chamfer size. And then you put a size here, like say 0.25, a quarter of an inch. And you can put a comment. So then I have that here. And then if I wanted to do, not that I would really do this, but if I had a chamfer there, I can come into here and say chamfer size. Not that you would do that, but to see the power of this, again, you could really nerd out. I can make this 1 inch. See how that chamfer updated? Super powerful, super cool. I use it all the time. You can use it for your jaw width. If you have, I've done it before, the size of my parallels. I believe I shared that in a previous live stream. So take a look at that. If not, just leave a comment and we'll get that to you. Okay? All right. So let me close this without a save. I don't want that chamfer to be in there. Okay. Because I've done some work and this device is linked to, so this is the document I'm currently in, Brad's part. I'm currently there. But I dropped this into this assembly, so that's why I'm getting that yellow update. It says a component is out of date. If I click this, it'll update it. And typically what I'll do is I'll go to design, and then I'll update it here. And I broke something. No, it's good. There it goes. Yeah, so make sure you're in design when you do that. All right. Coming back to manufacturing workspace. How's the questions, guys? Everything's good? All right, cool. Brad, thank you for posting the that link in there. All right. Great. Okay, so coming back to this, there's some things that we need to address. We were editing. Oh, you know what? We never finished that setup. I exited and we got sidetracked a little bit how I created that. Oh, and look what happened. Because I updated that vise and the stock, look at the stock. The stock is really small because it was linked. What I should have done is broken the link first, and to break that link, you could right mouse click. Oh, got it, sorry. Gotta be in design. Come over here and you say break link. What that does is it'll break the link between this document that's called Brad's part, and it breaks the link from where the source of this assembly is. So because it's still linked, I'm just going to come into here. I'm going to open this. I suppose I could use edit in place. They call it EIP. But I am a machinist, and I'm kind of stubborn, and I like to do things my way. Let me bring this guy here. And I remember that was 10.5 by, I think it was 8 by 4. Oh no, it was the other way around. It was 4 in Y and then 8 in Z. There we go. Now I can save this. You can also leave a comment here if you want to, but I can say updated stock size. And then here, when you look at this, you can see the note updated stock size. Super useful when you do revisions. Pro tip there for you guys. So now I'll come back to this. Brad's part. I'm in design. I can update it. Fusion's going to do its magic. And now if I look at my stock and the jaws, they have updated. So super useful. Be mindful of that. When you make a change in the source, it will carry over to wherever it's being used. Brad, thank you for handling questions. I don't see anything coming as far as questions. So time is going quickly, and let's go back to the setup in manufacturing. I'm just going to do a fresh setup, start from scratch. So we'll do a new setup. And the very first thing I'm going to look at is what am I going to machine? I want to machine, if I come to this part, remember this, I want to machine that part, and I also want to machine the support structure. The fixture, what's my fixture? I could just start grabbing things here if I wanted to. I could also grab them from this area here. All right. And then on the stock, instead of from preceding setup, I can say I want to get that stock from here, which was that stock that we had defined in this. Remember over here? That stock right there. That's this guy. Come over to this tab. And because I exited, I hit this tab, I lost my work. So be mindful of that when you're jumping in between. Make sure to hit OK on your setup. So let's go back here, do this one more time. This is not scripted, guys. I'm just going off the cuff here. So whoops, I'm not doing that. So where's my part and my support structure? I'm machining. My fixture is going to be the riser, and then all these parts that are part of that vise. Again, I need to just combine those into one. My stock is going to be from a solid, and I'm going to pick this guy here. Again, normally I would have a separate bucket that contains my stock. Where did I put that? This guy. But I'm not using it today. And then now that I got my stock set up, you can come in and post process. Give it a program number, 1, 2, 3, 4. And program comment. You can call it whatever you want. Op 1. done in one, whatever you want. WCS offset, I like to get in the habit of giving it a number 1. That will give you a G54 if you're on most machines. Now instead of hitting something else, I'm going to make sure to hit OK. So we maintain that. You know what? As I hit OK, I realize I completely missed my work coordinate system. I'm going to select my Z and X. So that's going to be my Z normal. And then my X normal, I'm going to grab this face. Where's my origin, my 0 point? Depending on who you ask, you'll get a different answer. Some people like to do it at the top center of the stock. I like to pick a fixed location. So I can pick, let's grab this arc here. I can grab this arc there. Make sure you don't grab this one, because then the Z, if you're looking at it from here, then the 0 wouldn't be on the table surface. It'd be actually up where that chamfered edge is. So be mindful of that. So with this highlighted, I'm going to grab this. So that'll be the top center of my table. I might even do it from the top center of this riser. Again, it depends on what you're doing and who you ask. So there's my orientation of my WCS. I've got my stock and I've given my information here. Hit OK, and with that we are ready to create some toolpath. So let me hide this visibility here manually there. There's another thing let me point out, guys. Again, just Angelo Machinist Nerd here. Down here in the bottom, I have 3 monitors on my desk, on my computer here, and this doesn't always work the best for me. When I click on this little flyout will open up on my screen below, but because there's a gap, I can't click anything. So look, if I maximize my screen, well, it's there now because I had it highlighted. But if I click on this, see, I'm clicking on that drop down or this drop down, I can't see it. It's bleeding off into space on another screen. So what I have to do, I have to come up here, and then I can come here, and now I can check these on or off. So I like turning this on because what this setting does, let's maximize my screen again. What that does, let's collapse some of this here. Depending on what setup you have and what's selected, the visibility will update. Now I have this guy turned on. So as we're toggling through, I must have a selection that's not right because that support structure should not be there. But what it does, it will show the proper visibility based on what you have selected. So you don't have to go through and dig in and dive in and make sure you turn on sketches and all of that. Super powerful, super helpful. I know that some people will be watching and saying, oh, you missed something you clicked. And it's possible. I'm a human and I make mistakes from time to time. So all good. And then what I would do is give this a name. Let's call this LiveStream Setup. And then I would start creating my toolpath. And because we're quickly running out of time, and I knew this would be a 2-part, I'm not going to get into that. I'm going to focus on the toolpath on the next live stream when I do this for part 2. But I would probably come in this orientation, and actually depends on who you ask. I could come in this orientation and rough everything from this surface up to get rid of that material up there. And then I would use another adaptive and tilt it sideways like this and machine everything I can in this from that tool vector and machine this cavity, machine all of this out of there, and then flip it over, do tool orientation and hit it from this side. And when I'm doing things like that, remember how I talked about I would create a plane. So let me turn this on. So I would use this plane. I don't need those sketches. I would use that plane as my Z depth. So that plane is here. So I can use that plane, and when I create a toolpath from this side, and I say this is my Z depth, and I go below that by a certain amount, and then if I just copy paste that operation, all I would have to do is use the same toolpath. If I copy paste it, it would maintain the boundaries, and I'm going to show this on part 2. It'll keep that boundary and that plane, but all I would do is flip the vector, flip the tool orientation, and it would then go to the same depth, but from this side. So always think ahead when you're doing things like that, because if I was here and I did this side and I said my Z depth, and again, guys, I'm going to cover this on the next one. If I said that's my Z depth and my tool is coming from this side here, and I'm machining all this away, and it goes a little bit below that. Now if I copy and paste that to do the other side, well, now that's the Z depth, and then I have to go ahead and select maybe this as the new depth. So always be mindful, be thinking ahead, think ahead as for your selection, so when you flip the vector or the orientation of your tool, that you can save yourself a few steps, because that rectangular boundary would remain the same instead of the tool coming from this side. If I use this, instead of the tool coming from this side, and let's say I had the plane there, and I said that was my Z depth, from say 5 millimeters below that plane, that was at the center of rotation, and when I flip it, I can maintain, and if I do a copy paste, I can maintain that same boundary, use that same surface. I don't have to do any manual selection. All I have to do is change the tool orientation from this side to this side and hit regen or generate. So those are some of the things that I do as a machinist to make a job like this easier. Let me take a look at if Brad dropped any questions. No, we're all good. Coming up on time. As I said, this is a privilege for me as a machinist. I've been a machinist for a while, that I get to share some of the things that are in my head, some of the things that I think about as a machinist, to give you guys some ideas. And like I said on this part, this is not the only way to machine this part. This is merely a suggestion. Let me hide all those guys. So I'm going to, with that, leave you guys to digest this and think about the manufacturing or machining process for this. And I do see a question from Marco regarding Rimats. Yes, I know Rimats. Mate came to visit San Francisco Pier 9 over a year ago or so. Peter says, Brad is a clock master. Angelo is now too. Yeah, I want to be mindful of your time, guys, and not go over too much. And we can just come back another time and finish up and carry on the conversation. That's all I have for today. We'll come back and do this a part 2 and show you how to machine that with the proper tool paths or suggested tool paths. My suggestion, if you ask some of my colleagues or buddies or friends, they might have a different workflow. Again, the suggestion on the screen, that's only my recommended way. There's many ways to approach that part and get the same result at the end. It's just a matter of, like I said, the quantity, the material, the cost of the material, cycle time, when do you need the part tolerances, all those things you need to consider as a machinist to make sure that you make the most of the time you have available and get the engineer the part as quickly as possible, on time, within spec, and also a good looking part too. I've said it before, anybody can make a part, but not everybody can make a beautiful part. Kind of like a chef. You can take the same recipe and put 10 people on that recipe, and the food will taste slightly different. And the better chef will always make the the better meal. So very similar in machining. I'm going to take a quick last look, and I think we're good. Brad, thank you so much. You're always very helpful and knowledgeable in what you do, and I appreciate working alongside you. Everybody else, thank you for spending time with us here today. We greatly appreciate it. Like I said, it's a privilege for us. And come back for the next live stream, and we'll carry on the conversation. Leave any comments or questions, and I'll do my best to answer those in a timely manner. And everybody be safe, and we'll see you next time. Bye.